Happy June, 8th graders! Today we are going to start working with parabolas. So the graph of a quadratic equation is called a parabola. So when we have the y-axis and the x-axis here, sometimes the axis of symmetry, this part that would split it in half, see how you could fold it over on each side so they would match? Sometimes this axis of symmetry is called the line of symmetry. Sometimes the x-intercepts are called the solution or roots. Of the quadratic equation. So very important things to know. A quadratic equation is an equation of the form y equals ax squared plus bx plus c. So it has this x squared term where a is not equal to 0. So if the coefficient a is positive, the parabola opens up. So a is positive. If the coefficient a is negative, the parabola opens down. So upwards open and downwards open. So determine if it opens up or down. So if a is positive, it opens up. If it is negative, it opens down. If it is positive, it opens up. Okay, so parabolas that open up have a minimum. See how they have a minimum? Parabolas that open down have a maximum. So the graph of a quadratic equation is called what? Called a parabola. Give an example from life where parabolas occur. So I always think of gravity. So some kind of force. So if I threw a football, or really anything, wouldn't it start from 0, speed up, and then come back down? Use the general formula for a quadratic function to answer the following questions. If a is positive, the parabola opens, remember, up. If a is negative, the parabola opens down. So here we're going to determine up or down. So if it's negative, it's down. If it's positive, remember the coefficient in front of the x squared term, it opens up. Positive, up, negative, down. Positive, up, negative, down, negative again, down, positive, up. Do you see that? Quick and easy, right? For 5 through 8, use the graphs of parabolas A and B pictured below. So what is the vertex of the parabola? A. So looking at A, remember the vertex is the minimum for one that opens up. So it looks like it's at 1. So 0, 1, because the x is 1. X is 0 and the y is 1. What is the vertex of parabola B? So since this one opens down, it has a maximum. Looks like the x is 5 and the y is 1, 2, 3. So we write it as an ordered pair because that's how we would find it on our coordinate plane, right? Give an equation for the axis of symmetry of each parabola. So these would all be x equals something. So what does x equal right here for parabola A? 0, right? and x here, this line of symmetry, x equals 5, right? Not so bad so far, huh? Which parabola opens up? So A, right? Which parabola opens down? B. Which parabola has a maximum? Well, these go up, up, up forever. So this is the only one that has a maximum. So that's parabola B. And which one has a minimum? These go down, down, down forever. So A is the only one with a minimum. Does that make sense? Are you guys seeing minimum, maximum, how they're opening? All right. It shows the height h in feet of water t seconds after leaving the mouth of a fountain, and it gives you the equation. So what is the greatest height the water reaches? So if I'm looking at the vertex, that's the maximum, right? It looks like 16 feet. How long is the water in the air? So if it starts at 0 seconds and ends at like 2.5 seconds, it's in the air for 2.5 seconds, right? How high is the fountain's mouth? So when it starts right at 10, so the fountain's mouth must be at 10 feet, right? What is the height of the water after 2 seconds? So looking at 2 seconds, we find our y value, which is also 10. Find the height of the water after 1.7 seconds. Use the formula, not the graph. So I'm putting the time in here. So I have -6, and then for t, I'm putting in 1.7 seconds. Remember, that's squared plus 12 times 1.7 seconds plus 10. So I would most definitely use my calculator. So I have 1.7 times 1.7, which is 2.89 times that -6. So I'm just going to say times 6 for now. So I have -17.34 plus, we have 12 times 1.7 equals 20.4 plus 10. So this is 30.4, so I'm going to add 10 to that, and then I'm going to subtract 17 and 3400ths. So minus 17.34. So we have 13.06 feet. Do you see how we solved for the height by putting in how long it was into the formula? So how long is this rocket in the air then? So from 0 to 8 seconds, right? What is the greatest height the rocket reaches? Ooh. Are those going up by 10, 20, 30, 40, 50? So it looks like close to 260, maybe just below that. We'll say 255 feet. About how high is the rocket after 1 second? Here's 1 second right here. So what, like 105, because it's not quite to 110? After 2 seconds, about how high is the rocket? So I'm finding 2 down here, and I'm seeing what my y value is. It looks like 190. Is the rocket going up or coming down after 2 seconds? It's still going up, right? After 6 seconds, about how high is the rocket? So here's our 6. It's about the same as it was at 2, so 190 feet, we'll say. And here is the rocket going up or coming down. Now it's coming down, right? Do you see how we read a parabola? We know if it's opening up or down. We have minimums and maximums. Yeah, axes of symmetry and vertex too. All right. Have a fantastic Tuesday.